In this time, I will talk about the screening effect. And as you know, solids is composed by electron ions, and the ion is background, and the ion is positive ion is background, and it is positive ion. If we think about the positive ion, then the negative charge attracts nearby the positive ion. Therefore, and it kind of the electron cloud is surrounded near the positive ion, and therefore, and we call in this case, then there is a potential. If we think about that, the single ion potential, it is a Coulomb potential. Then this kind of Coulomb potential in a single ionic potential, but in this case, then the ionic cloud can screens out this positive potential. We call it is a screening effect. And the positive charge, then therefore I will write down the physical interpretation. And at first, it is a free electron screening. And positive ion is placed in a stationary state in a position and attracts electrons because the positive ion is plus and the negative ions attract with each other by the Coulomb potential, and negative charge in the neighborhood nearby the positive ion screens its electric field. Screens out the potential. And here, in this case, let's think about that Poisson equation. We should think about this Poisson equation by the electrostatic potential. The electrostatic potential by positively charged particles. And let's say that it is a phi external. The phi external is the positive charge particle potential. Then the Poisson equation is that we should solve the Poisson equation in the electrostatic problems, and minus Laplacian phi external as a function of r is that 4 pi rho. Here rho means that external charge, and particle charge density, and here rho external r is that particle charge density, and we should solve the Poisson equation. And here, if it is a bare electron, it is bare ion, not bare electron, bare ionic potential. And then the electron attracts nearby the electron cloud attracted by the positive ion. And here, in this case, let's think about phi r is that the potential by ions and electron cloud. Yeah, like this kind of electron and positive ionic charge cloud. Then, in the case of potential, we say that it is phi. Then the Poisson equation on this system on the electron cloud is that minus Laplacian phi should be 4 pi rho, and we should solve this Poisson equation, and then the rho can be think about that external R by the ions and plus induced charge by electron, and therefore the charged clouds can think about it is charged it is charge density of ions, and it is an electronic cloud. Therefore, the net charge density can be cancelled out with each other, and because charge density of ions plus and the electron cloud is minus, and it cancel the charge. Here then the external potential, because there is electron and ion interaction, and there is a dielectric constant there, because in this case it is plus and minus, and there is if we in somehow if we apply the electric fields, this electronic and ion clouds can be decomposed, or other makes polarization, and therefore we should think about it is dielectric, and the dielectric means that plus and minus pair can be formed in plus minus pair, and the dipole moment direction is that it is a dipole moment, and like this. In this case, then the dipole moment can define that epsilon. Epsilon is the dielectric constant, and the dielectric constant is related to the electron and ion coupled oscillator, and therefore here the external potential has a relation with that real potential, and real potential is screened out by the epsilon r and r prime, and also we should integrate in overall space, and then it is the ionic potential, and here this dielectric the dielectric function for a uniform electron gas, and the epsilon r and r prime is that epsilon r minus r prime. It only depends on the relative coordinate, the ion and electrons, and therefore this external potential, the ionic potential can be obtained by the dr prime epsilon r minus r prime and phi r prime. Then it is real. It is if we think about that Fourier transform on this case, and this real space epsilon can be transformed by the momentum space epsilon, and real space phi becomes momentum space q, momentum space phi, and if we make a Fourier transform, I already say many times that in solid we should think about that the momentum space information, and here the epsilon q is that the Fourier transform of the epsilon in real space, the exponential minus I q dot r and epsilon r. It is Fourier transform of dielectric function in real space to the momentum space, and inversely, the real space can be write down, and here dq over 2 pi cube is the unit of the momentum space, and exponential iq dot r epsilon q. It is this relation is the Fourier transform relation in real space and momentum space of dielectric function. Here from this equation, the phi q is that potential is that 1 over epsilon q and phi ionic potential, and therefore the ionic potential screened out. Ionic potential is screened out by electronic clouds, and electronic clouds make the dielectric function, and also that gives rise to the potential and total potential. And here it is potential description. And how about the induced charge density? Here in induced charge density, we define that electronic susceptibility chi in the linear response by potential linear response by a potential is that it makes that the induced charge in momentum space, and the potential gives rise to the induced charge. Then the coefficients, and the linear coefficient, we call it is chi, electronic susceptibility. And here this potential makes that the induced charge here, the chi is that the electronic susceptibility, and also here chi q is that for a given potential, and it gives rise to the induced charge. It is that implicit definition of the electronic susceptibility. And we think about the Fourier transform of Poisson equation. Then the Laplacian and the integration of here we know that it is real space Poisson equation. It is a real space Poisson equation. And then the Fourier transform, here phi r becomes that dq over 2 pi cube, and exponential I q dot r, and the phi external q from this above equation. And then it is that 4 pi integral, it is integral dq over 2 pi cube exponential iq dot r rho external r. Here we come from the Poisson equation by the external potential. we applied this Poisson equation, not this one. Therefore, and by the second derivative with real space, and therefore IQ should be this IQ should be to the square. Therefore, minus q square is appeared, and also the integral dq over 2 pi cube is generally obtained in both side, and exponential IQ are also, and this can be think about that the q square phi external potential is that 4 pi rho. And it means that in the same way, and q square phi q from the total charge Poisson equation is that 4 pi rho q. And here, when subtract in from bottom side to the upside, and here q square over 4 pi, and let's think about phi q minus phi external q is that rho q minus rho external q. Then it is definition of the induced charge. It is induced charge q. Then we already know that the induced charge makes that this kind of potential relation with electron susceptibility, and therefore it is chi q and phi q. Therefore, and by using this, phi q is phi q and phi q, let's combine together, and the phi q, then here q square over 4 pi minus chi is that q square over 4 pi phi external potential. Therefore, the potential, the total potential is that let's divide in the numerator in both sides, q square over 4 pi, and the 1 minus 4 pi of q square chi q, and phi external potential. Then it is that here from this phi is that external potential divided by the epsilon, and here therefore it is that 1 over epsilon q and the phi external potential, and therefore it means that the epsilon dielectric function in momentum space can be think about 1 minus 4 pi over q square chi q. Then it is a relationship between the electron susceptibility and dielectric function, and in other words 1 minus 4 pi over q square, and here chi q here from this chi q is that the induced charge divided by the potential, and therefore here it is a induced charge over potential. And here it is a definition or the relations of the dielectric function. Basically, when you think about this one, and the dielectric function is originated from the potential. Potential makes the induced charge and this vector, and therefore, and when you think about there is no induced charge on a single ion, then the epsilon is 1. But in general, in the ionic potential clouded, the cloud of electrons surrounded in the ions, and it reduced this value, the dielectric function. Basically, the dielectric function is it implies the reduction of potential from the ionic potential.